Welcome to my channel. Today we are going to discuss about the multiple choice question and answer from the topic lossless transmission line and distortionless transmission line from the subject transmission lines and waveguides, transmission lines and RF system. Okay, so already I posted the three videos for this unit 1 transmission line theory. Okay, if we want to learn the remaining videos, I will give link in the description box. You can refer it. Okay, so the first one, the transmission line is said to be lossless when the dash. So which transmission line is said to be lossless? So the name itself answer is there, lossless. Lossless means there is no loss. Okay, so if the conductor is perfect and the dielectric is lossless means that transmission line is called as lossless transmission line. So for a lossless transmission line means there is no loss, okay, or there is no attenuation. So which transmission line is having no loss or attenuation? That transmission line is called as lossless transmission line. Okay. Then the next one, the distortionless line is one in which the attenuation constant and the phase constant are independent of frequency. This statement is true or false. Okay. Distortionless line, lossless line is different, distortionless line is different. So in a distortionless line, the attenuation constant alpha and the phase constant beta both is independent of frequency. The statement is true or false. It's a false. Okay. Yeah, what is the thing? What is the correct statement of this second question means in a distortionless line, the attenuation constant is independent of frequency. Okay, but the phase constant beta is linearly varying with respect to frequency. This is the correct statement for distortionless line. So for a distortionless line, the attenuation constant alpha is independent of frequency. Then the phase constant beta is linearly varying with respect to frequency. Okay. Then the next one, the resistance of lossless transmission line is dash. Okay. Already you know lossless transmission line means there is no loss, there is no attenuation. So that's why the resistance R value of lossless transmission line is 0. Okay. Resistance value of one lossless transmission line is 0. Okay. Then the next question, which two parameters given below are 0 in the lossless line? Okay, so which two parameters, there are, that is the primary and secondary parameters are there for a line, transmission line. So which two parameters are 0 in a lossless transmission line? So for a lossless transmission line, the G value and alpha value equal to 0. Okay, G is the conductance. Conductance value is 0 as well as the attenuation constant. Okay, since you know lossless transmission line means there is no attenuation. So the attenuation value, it is equal to 0. Then the next thing, the characteristics impedance of a line having the primary constant L and C as 35 millihenry and 70 microfarad respectively is dash. So the question is, we have to find the characteristics impedance Z0. What is mean by characteristics impedance Z0? The Z0 with the primary constant LC is 35 millihenry and 70 microfarad. So you know the formula for characteristics impedance in terms of the primary constant L and C. Okay, what is the formula? So already we discussed, we derived this Z0 value in the previous video. So the Z0 is equal to square root of L divided by C. So what is the L here? 35 millihenry. So 35 into 10 to the power minus 3 divided by the capacitor is 70 microfarad. So 70 into 10 to the power minus 6. Okay, so if you are solving, we will get the answer is 22.36 ohms. Okay, so the answer is 22.36. Okay, so this question is a 2-mark problems. So characteristics impedance, we have to find out the given data is L and C. Okay, then the next question, the attenuation constant is measured in the unit of dash. Okay, so you know the what is the unit for attenuation constant? It's a Nieper. Okay, the attenuation constant, it is mentioned by attenuation means, you know, the rate at which the wave gets propagated. Okay, the wave get attenuated per unit length, it is called as attenuation constant. So the attenuation constant is usually measured in Niepers. Then the next one, the velocity of transmission line with frequency is 35 radians per second, and the phase constant is 68.5 is dash. So here the question is, we have to find out the value of velocity. What are the two data given? The frequency given and the phase constant beta is given. So here the frequency, you see what is the unit? 35 radians. So radians means F is not given, omega is given. So we have to find out the value of velocity. So what is the relation between these three things? So already you know the relation. The velocity V is nothing but it's a ratio of radian frequency divided by the phase constant. Okay, so 35 divided by 68.5. Okay, so 35 divided by the 68.5. So we will get so the velocity value V, it's a ratio of omega divided by beta. So omega is given as 35 and beta is given as 68.5. So if we are calculating, we will get the answer is 0.51. Okay. Then the next one, the condition that holds good in a distortion less transmission line is dash. Okay, that is what is the condition for the distortion less transmission line? R by L equal to G by C, RL equal to GC, some different value is given. So which one means for a distortion less transmission line, the primary constants are related by R by L is equal to G divided by C. Okay, or otherwise, if you are cross multiplying, we will get RC equal to LC. Okay, these are all the condition for distortion less line. Okay, you just remember this. This is a very important question. For a distortion less line, the condition is that the ratio of resistance by inductance is always equal to the ratio of conductance by capacitance. Okay. Then the next thing, if R, L, G, C are respectively the resistance, inductance, conductance and capacitance per unit length of a transmission line, then the heavy side condition for a distortion-less transmission line is dash. Okay, so already the same thing, the same question only. What is the condition for distortion-less transmission line? So here the question is differently asking that RLGC is the primary constant. Then what is the condition for distortion-less transmission line? The same thing. So the ratio R divided by L. Okay, the ratio of resistance divided by conductance, inductance is always equal to the ratio of conductance divided by capacitor. But this condition is not given here. Okay, so you see, you just cross multiply this one. So if you are cross multiplying, we will get RC equal to L into G. So the second one, RC equal to LG. This is the correct answer. Then next one, given that R equal to 20 ohm, L equal to 40 millihenry, C equal to 40 microfarad, G equal to 0.02 mho. Find whether the line is distortion less or not. Okay, so this is the problem. So already you know, if the line is distortion less line means, so the condition is that it should satisfy the condition R by L ratio is always equal to the ratio G divided by C. Okay. So in order to check this line is distortion less line or distorted line, so we have to check. So what is R by L? What is the value of R? 20. So we have to find the ratio. First R is 20 divided by L. What is the value of L? 40 millihenry. So 40 into milli 10 to the power minus 3. This ratio is always equal to G divided by C. What is G? It's a 0.02. Okay, similarly divided by C is 40 microfarad. So 40 into Micro means 10 to the power minus 6. So you just calculate the ratio of this one and this one. If these two ratio is equal means we can say that the given transmission line is a distortionless line. So this two thing is equal. So that's why the given line is that distortionless line. Okay. Similarly, the next question, for a distortionless line, R equal to 20, G equal to 0.8 mho. Then what is the attenuation constant? Okay, so for a distortionless line, the attenuation constant alpha formula is that it is a square root of R into G. Okay, for a distortionless line, the attenuation constant alpha is reduced to square root of R into G. So you just substitute the value of R and G. So R is 20, G is 0.8. So you just multiply and find out the answer. So alpha equal to 4. So the attenuation constant is 4. So this is also one of the 2-mark problem. Okay, for a distortionless line, if R value, G value given means you just find the attenuation constant. Then the next question, the velocity of the electromagnetic wave with the frequency is 6 megahertz and the skin depth is 1.6 micrometer. Okay, what is the velocity of that electromagnetic wave? So the velocity of wave, it is nothing but it's a product of frequency and skin depth. So you just multiply the frequency 6 megahertz with the skin depth 1.6 micrometer. If we are multiplying these two, we will get the velocity. So the velocity answer is, it's a 9.6. Okay, if you are multiplying these two, 6 megahertz means 6 into 10 to the power 6 and 1.6 micro. So 1.6 into 10 to the power minus 6. So 10 to the power 6, 10 to the power minus 6 cancel. If we are multiplying, we will get the 9.6 is the answer. Then the next question, the characteristics impedance of the distortionless transmission line with R equal to 45 ohm and G equal to 0.45 mho is dash. Okay, so already you know, for a distortionless line, the attenuation constant in terms of R and G is square root of R into G. Okay, similarly, for a distortionless line, the R G is given means how to calculate the characteristics impedance. Okay, already you know the characteristics impedance formula. What is the characteristics impedance formula in terms of L and C? Is that not equal to square root of L divided by C? So already you know for a distortionless line, what is the condition? That R by L is equal to G divided by C. So that's why the square root of L by C is always equal to square root of R by G for this distortionless line. Okay, so therefore square root of what is the value of R? 45. What is the value of G? 0.45. So the answer is 10 ohms. Okay, so 10 ohm is the answer. So for a distortionless line, the characteristics impedance in terms of R and G is square root of R by G or square root of L by C. Okay, then the next one, a line which has neither frequency distortion nor phase distortion is called distortionless line. It's a true or false? True. Okay, what is mean by distortionless line means in a transmission line there is no frequency distortion as well as the phase distortion, means that transmission line is called as distortionless line. Okay, then for a distortionless line, which one is true? Okay, so you see the first statement, attenuation constant should be made independent of frequency. The phase constant should be made dependent on frequency. The velocity of propagation is independent of frequency. All of the above, all of the above. So for a distortionless line, attenuation constant alpha is independent of frequency. Phase constant is linearly varying with respect to frequency. Velocity of propagation is independent of frequency. So all of the above is true in terms of distortionless line. Okay. Then how the telephone line can be made distortionless line? So in order to make the telephone line as a distortionless line, so the inductance value should be increased. Okay, in the inductance value of that particular cable, we have to increase by placing lumped inductors along the line. Okay, we have to place the inductors along the line. If we are placing the inductors along the line, the telephone cable to be a distortion less line. The next thing, the distortions occurring in the transmission line are called dash. Waveform distortion, line distortion, both A and B. Both A and B. The distortion produced in the transmission line, it is called as waveform distortion. The other name is line distortion. Okay, both A and B is the answer. Then what are the types of waveform distortion? So there are two types of waveform distortion or line distortion. One is frequency distortion. Another one is phase or delay distortion. These are all the two type of distortions occur in a transmission line. Okay. Then what is mean by frequency distortion? Okay. So the signal, when a signal having many frequency components are transmitted along the line, all frequencies will not have equal attenuation. Okay, so hence in the receiving end, we will not get all waveform reach the receiver not in a same time. Okay, so each signal will sending to the, okay, so the received end waveform will not be identical with the input waveform at the sending end. So because each frequency is having different attenuation. So this type of distortion is called as frequency distortion. Okay, when the signal from the transmitter, it consists of many frequency, means each frequency component is having different value of attenuation. So in the receiving end, if you are receiving the signal, that attenuation is also varying. So that's why we will produce that type of the different attenuation produces the deviation in the shape of the signal. It is called as a frequency distortion. Then what is delay distortion? So when a signal having many frequency components are transmitted along the line, all frequencies will not have the same time of transmission. Some frequencies are delayed by some others. Okay, so that's why in received end, we will not get the identical waveform of the input waveform. Okay, so that type of distortion due to the delay, it is called as a delay distortion or phase distortion. Okay, then the next one, how to avoid the frequency distortion that occurs in the line. So if we want to reduce the frequency distortion occurring in the transmission line, so the attenuation constant should be made independent of frequency. Okay, by using the equalizers at the line terminals. So if you are placing the equalizers in a transmission line, which minimizes the frequency distortion. So in order to avoid the frequency distortion in the transmission line, we have to make the attenuation constant should be independent of frequency. So in order to make attenuation constant independent of frequency, we have to place equalizer. Okay, we have to place equalizer at the line terminal, which minimizes the frequency distortion. Okay, so these are all the some of the questions from the distortions, waveform distortion in a transmission line and a distortion less transmission line. Okay, so thanks for watching my channel, and please subscribe my channel for more videos, and share this video to your friends also. Okay, so if you want to learn the signals and system MCQ and DSP MCQ, electronic circuits II MCQ, circuit analysis MCQ, in my channel there is a separate playlist is created for each subject. Okay, so you go and learn, or otherwise I will give link in the description box, you can use. Okay, so thank you, we will meet in the next video.